In 1849, the British archaeologist Austen Henry Layard was excavating the ancient ruins of Nineveh in what is now northern Iraq, when his team uncovered something that would take over a century and a half to even begin to understand. Buried in the rubble of the great Library of Ashurbanipal, among thousands of cuneiform tablets, cataloging everything from trade receipts to royal decrees, was a circular clay disc, roughly the size of a dinner plate. It was cracked. Portions of its surface had eroded away, but what remained showed 8 distinct sectors filled with cuneiform text and geometric line drawings that did not match anything else in the collection. The British Museum catalogued it as tablet K8538. For decades, nobody could figure out what it was. It did not read like a legal document, a religious hymn, or a record of conquest. The symbols seemed technical, even mathematical, but the framework for interpreting them did not exist yet. It would take until 2008 for 2 engineers from the University of Bristol to offer a translation that would change the conversation entirely, and what they claim that tablet actually recorded is, depending on who you ask, either the most significant astronomical document in human history, or one of the most ambitious misreadings of ancient text ever published. This is the story of what the Sumerians carved into clay about the sky above them, what they apparently knew about the planets orbiting our sun, and why a growing number of researchers believe one specific marking on that disk does not just map a distant world. It designates it as something aware of Earth. The civilization that produced the original version of that tablet, the culture the Assyrian scribes were copying from, was already ancient by the time Ashurbanipal built his library around 650 BC. We call them the Sumerians. They emerged in southern Mesopotamia in the fertile land between the Tigris and Euphrates rivers, and by roughly 4500 BC, they were building cities, developing irrigation systems, and creating what many scholars consider the first written language on Earth. Cuneiform, their writing system, involved pressing a reed stylus into wet clay to create wedge-shaped impressions. It is crude by modern standards, but what the Sumerians did with that crude tool is staggering. They used it to record complex mathematics, legal codes, medical procedures, and astronomical observations so detailed that some of them remained more accurate than European models well into the Middle Ages. Their number system was base 60. That is why we still divide hours into 60 minutes and circles into 360 degrees. These were not arbitrary choices. The Sumerians developed base 60 because it was mathematically convenient for tracking the movements of celestial bodies across the night sky. They tracked those movements with a discipline that borders on obsessive. The Alepian tablets, compiled around 1000 BC but drawing on observations that stretch back much further, represent one of the earliest comprehensive star catalogs in existence. They list stars, constellations, and planetary bodies organized by their rising and setting patterns relative to the horizon. They include calculations for the length of daylight throughout the year. They describe the paths of the moon and the 5 planets visible to the naked eye with a precision that Greek astronomers would not match for another 500 years. The point is this: when we talk about the Sumerians recording information about the cosmos, we are not talking about primitive people drawing pictures of things they did not understand. We are talking about a civilization that built the mathematical scaffolding our own timekeeping still rests on. When a Sumerian scribe carved astronomical data into clay, they meant something specific, and that is what makes tablet K8538 so difficult to dismiss. Alan Bond and Mark Hempsel spent 8 years working on the Nineveh planisphere before publishing their findings in 2008. Bond was an aerospace engineer. Hempsel was a senior lecturer in astronautics. Neither of them were archaeologists, and that mattered because the academic response to their work reflected it. But what they brought to the table was something Assyriologists generally don't have. They understood orbital mechanics. Their approach was computational. They took the surviving cuneiform symbols and geometric angles on the tablet, fed them into modern astronomical software, and searched for a date when the night sky would have matched the positions described on the disk. The software returned a match: June 29th, 3123 BC. According to Bond and Hempsell, the tablet recorded a specific observation made on that date, tracking an object moving across the sky from the constellation Pisces toward the constellation of the Plough. They identified it as an asteroid more than 1 kilometer in diameter and connected its trajectory to a known geological event, the Kofels impact site in Austria, where a massive landslide occurred roughly 5,000 years ago that has never been satisfactorily explained by conventional geology alone. Now, mainstream Assyriology pushed back hard. The objections were reasonable. The tablet is damaged, meaning any reconstruction involves filling in gaps. The cuneiform readings are contested. Applying modern orbital software to a 5,000-year-old clay disk involves assumptions about accuracy that many scholars consider unjustified. But the Bond and Hempsell decoding did something important, regardless of whether their specific conclusions hold up. It reframed the planisphere as a technical observation document, not a prayer, not a myth, not a decorative object, an instrument. And once you accept the possibility that the Sumerians were recording precise astronomical data on tablets like this one, the door opens to a much more uncomfortable set of questions about what else they may have been recording. One of those questions centers on a small Akkadian cylinder seal held in the Vorderasiatisches Museum in Berlin. Catalogued as VA 243, it dates to approximately 2500 BC, and it shows a scene that at first glance looks like a standard presentation, a seated figure, possibly a deity with attendants. But in the upper left corner of the seal is a symbol that has generated decades of debate. A large radiant body surrounded by 11 smaller spheres of varying sizes. The late author Zechariah Sitchin, in his 1976 book, The 12th Planet, argued that this image represents a complete map of our solar system, including the Sun, all 9 planets known today, Earth's moon, and a 12th body, Sitchin, called Nibiru, which he claimed orbits the Sun, on a highly elliptical 3,600-year cycle. Sitchin went further. He argued that the Sumerians did not just know about these bodies, they knew which ones were inhabited. He also identified specific cuneiform terminology that he claimed the Sumerians used to distinguish between worlds that held life and worlds that did not. The academic response to Sitchin has been, for the most part, devastating. The Assyriologist Michael Heiser published a detailed rebuttal arguing that the central symbol on VA 243 is a star, not the Sun. He argued that the surrounding spheres do not correspond to known planets in either number or arrangement. He also argued that Sitchin's translations of key cuneiform terms were, in Heiser's words, without basis in any known Sumerian or Akkadian lexicon. That should have been the end of it, but it was not. The reason it was not is that Sitchin's broader claim about Sumerian astronomical knowledge, stripped of his more extreme interpretations, keeps bumping into things that mainstream scholarship has trouble explaining. Take the Enuma, Anu, and Lil, a massive series of cuneiform tablets containing roughly 7,000 celestial omens, compiled over centuries of observation. This is mainstream, accepted scholarship. Nobody disputes these tablets exist, or that they contain sophisticated astronomical data. What's contested is interpretation. Within these texts, celestial bodies are described using language scholars have traditionally classified as astrological metaphor. Planets are given attributes. Some are described in terms that translate roughly to living or bearing life. Others are described in terms closer to barren or empty. The standard academic position is that these are poetic or ritualistic designations. The Sumerians and Babylonians personified their planets. Mars was Nergal, god of war and death. Venus was Ishtar, goddess of fertility and life. The language of living and dead worlds, in this view, reflects mythology, not observation. That's a reasonable interpretation, but it assumes we know for certain that the Sumerians were always speaking metaphorically when they described celestial bodies. That is a harder claim to defend than it sounds. because in many of these same tablets, right alongside the mythological language, you find precise mathematical calculations for orbital periods that match modern measurements to within fractions of a percentage point. These people were not confused about what they were looking at. They knew the difference between a story and a measurement. The term that generates the most controversy is Nibiru. In the Mule Apin tablets, Nibiru appears as a celestial reference point associated with the god Marduk. The standard translation identifies it as Jupiter, or possibly as a specific point in Jupiter's orbit where it crosses the ecliptic. That is the mainstream position, and it is well supported by the textual context. But there are other references, scattered across multiple tablets from different periods, where Nibiru seems to operate differently. In some texts, it is described as a body that crosses or passes through, which is consistent with a planet on a long elliptical orbit. In the Enuma Elish, the Babylonian creation epic, Nibiru is described in terms that seem to give it agency. It moves, it observes, it establishes order among the other celestial bodies. Again, the standard reading is mythological. Marduk is a god. Nibiru is his star. The language of observation and agency is personification. That is probably correct, but probably is doing a lot of work in that sentence, and the scholars who use it know that. If you are finding this useful, consider subscribe. This channel covers ancient civilizations and the genuine mysteries that mainstream history has not resolved. More content like this is on the way. The concept of celestial watchers in Mesopotamian cosmology is where this story takes its most unsettling turn. In Sumerian astronomical texts, certain bodies are described using a term that multiple translators have rendered as those who observe or the watching ones. The exact cuneiform signs are debated, because many of these tablets survive only in fragments, and the scribal tradition of copying older texts means any given tablet may contain errors introduced over centuries of transmission, but the concept itself is consistent across sources. Certain celestial bodies were not just present in the Sumerian sky, they were, in the language of the text, paying attention. The most famous parallel to this idea comes from outside Mesopotamia entirely. The Book of Enoch, a Jewish text dating to the 3rd century BC, but claiming to preserve much older traditions, describes a class of beings called the Watchers, who descend from the sky and interact with humanity. The Enochic tradition places these Watchers among the stars, and describes them as possessing knowledge of astronomy, metallurgy, and other sciences that they transmitted to humans. The connection between the Mesopotamian astronomical watchers and the Enochic watchers is not a fringe observation. It has been explored by mainstream scholars of comparative religion, including Helge Kvanvig and John Collins, who have documented the textual pathways through which Babylonian astronomical concepts entered Jewish apocalyptic literature. The question is not whether the connection exists, it is what the Mesopotamians originally meant by the concept. If the watching designation is pure metaphor, then it is an interesting linguistic artifact and nothing more. But if the Sumerians were using that term to describe a specific observational relationship between a celestial body and Earth, then the implications change substantially. The Sumerian king list adds another dimension to this puzzle. This document, preserved across multiple copies from different periods, lists rulers of Sumerian cities stretching back before the flood. The earliest kings are assigned reigns of tens of thousands of years. Alulim of Eridu ruled for 28,800 years. Alalgar ruled for 36,000 years. After the flood, the reigns dropped dramatically, eventually reaching historically plausible numbers. The standard interpretation is that the pre-flood reigns are mythological, perhaps representing dynasties rather than individuals, or reflecting a different counting system, but several researchers have noted that the specific numbers assigned to these reigns correspond to known astronomical cycles. 28,800 is divisible by the Sumerian mathematical base of 60 in ways that map to observable celestial periodicities. This has led to the hypothesis that the king list is not recording political history at all, but rather astronomical observation periods, measured in units, that later scribes misunderstood as human lifespans. If that hypothesis is correct, then the Sumerian king list may be, in part, an astronomical record of extraordinary length, and a civilization that was tracking celestial events across tens of thousands of years would have observed things we can only speculate about from our brief modern window of technological capability. The Enun tablets compound the problem. These astronomical records, portions of which survive in collections across multiple museums, contain positional data for celestial bodies that some researchers claim exceeds what should be achievable with naked eye observation. The precision of certain angular measurements has been compared to what became possible only after the development of the telescope in the 17th century. The mainstream explanation is that these measurements are mathematical extrapolations, not direct observations. The Sumerians and Babylonians were brilliant mathematicians. They could calculate where a planet should be, even if they could not see it clearly enough to confirm the calculation with their eyes alone. That is a valid argument, but it raises its own questions. Why calculate positions for bodies you cannot observe? What motivated the development of mathematical models for objects beyond the threshold of visual confirmation? The answer might be simple intellectual curiosity, or it might be that they had observational data from a source we have not accounted for. This brings us to the specific claim at the center of this video. Among the markings on the Nineveh planisphere, certain researchers operating outside the mainstream academic consensus have identified what they describe as a differentiated symbol. One marking among the celestial bodies represented on the tablet carries additional cuneiform notation not found on the others. The interpretation, and this is explicitly contested, is that this marking designates a particular body as directionally oriented toward Earth, not orbiting randomly, not drifting passively, oriented with, in the language of the proposed translation, a quality of attention. The mainstream position is clear. This reading is not supported by the established cuneiform lexicon. The damaged state of the tablet makes definitive identification of individual symbols unreliable, and the tendency to find patterns that confirm a desired narrative in fragmentary ancient texts is a well-documented problem in pseudo-archaeology. All of that is fair, but here is what the mainstream position does not do. It does not explain why the Sumerians possessed astronomical knowledge of the scope and precision they demonstrably had. It does not explain why their texts consistently describe certain celestial bodies in terms that imply awareness, observation, and directed attention. And it does not explain why this specific set of ideas, watchers in the sky who possess advanced knowledge and maintain an interest in human affairs, appears independently across multiple ancient cultures, separated by thousands of miles and thousands of years. The Fermi paradox asks a simple question. If the universe is vast enough to almost certainly contain other intelligent life, why have we not found evidence of it? One possible answer, explored seriously within the SETI research community, is that evidence may already exist in the historical record, but we have been categorizing it as mythology. The astronomer Carl Sagan raised this possibility in 1966. In a paper co-authored with Iosif Shklovsky, they suggested that accounts of contact with non-human intelligences in ancient texts deserved serious examination rather than automatic dismissal. Sagan was not endorsing the ancient astronaut hypothesis. He argued that a civilization advanced enough to reach Earth would likely have visited when human cultures were young, and that any record of such contact would naturally be expressed in the religious and mythological language of the time. The Sumerian astronomical tablets sit at the exact intersection of that argument. They are, undeniably, the product of a civilization that understood the sky better than anyone should have at that stage of technological development. Their texts describe celestial bodies in language that sometimes reads as metaphor and sometimes reads as data, and among those descriptions are references to entities or bodies that watch, that observe, and that maintain a particular relationship with this planet. Whether that means what the most provocative interpretations suggest is a question no one can definitively answer, not the mainstream scholars who dismiss it, and not the independent researchers who champion it. The tablets are damaged. The translations are contested, the originals that the Assyrian scribes were copying from are lost, but the artifacts themselves are real. They sit in museums in London, Berlin, and Baghdad. They have been photographed, measured, and catalogued by institutions with no interest in sensationalism, and what they contain, at minimum, is proof that the Sumerians were watching the sky with a discipline and precision that we are still working to fully understand. The question is whether something in that sky was watching them back. If this video gave you something to think about, the next one goes deeper into the specific Mesopotamian texts that describe beings arriving from a celestial body the Sumerians called the crossing place. It is already in production.